All right, so welcome back. This is the second episode in Modular Synthesis Module Design 101. And in the last episode, we worked on a schematic to build a buffered mult. And we got it ready for PCB layout. So we're going to continue from there. And yeah, let me take us through to where we were. Right, so we were looking at this schematic, and we had created some sheets, sheets for each of the buffers, as well as a power input. And yeah, so each buffer input is split three ways, as well as showing an LED indicator. Right, and also we had normaled the input of the jack on the first channel into the input of the second jack. So if nothing's connected there, we'll get the signal out through 6 outputs instead of just 3. All right, so we are now at a point where we want to start the PCB design, but subsequent to recording the last video, I noticed just a little tweak that I want to make on the schematic before we go and harden everything on PCB. So I'm just going to move this resistor to the other side of the LED. And actually the reason I want to do this is it's not that I think it makes much of a difference because it's a bidirectional LED, but you'll see the resistor on each of the outputs of the quad buffer. I thought I would simplify just the schematic a little more by pulling these resistors into the actual quad buffer unit that we created. So I'm going to just copy them, and before the output of each, I'm going to paste those resistors. So let's just drag each of these out a little bit. It'll just simplify the main schematic just a tad. As well as if we want to change values of resistors, then we've only got one place to do it in. So that is kind of cool. So now both quad buffers have got, or should have, perfect, those resistors in there, which means we can remove them from here. Right, all of those ones as well. And just join up those lines. Okay, and this side as well. Okay, great. I guess we could also do the same thing with these 1M resistors on the front end of the input. So let me just do that. Go. So we had a resistor to ground on the input. So I'm going to press P for power, find ground, hit enter, and there we go. So now that's on the input of both of the quad buffer, should be. Interesting, I might have to reannotate because I noticed that it's the same reference now on both. So let's see what happens. Let me first remove these ones. Just simplify this a little bit. And back our ground over here. Okay, so now potentially it's a little easier to see what's going on. Without all those extra components. I'm just going to save this, and I'm going to click on this symbol up here, which is assigning footprints. Is that what I want? Annotate. Now I want to annotate the schematic. So I'm just going to, the entire schematic. So in other words, all sheets recursively into subsheets. Reset the existing annotations. And the annotations, by the way, are these references. They need to be unique identifiers for each of the components that we use. So I'm going to do that. Reannotate. It says it's complete. Let's go and check those pages. R1, 1M, R6, 1M. Okay, that looks better. Okay. Then, since I've reannotated, so things have got different references than they had before, I'm just going to go back to the PCB and re-import the whole bang shoot. Let's just see what it does. So I should now, if I put these side by side, I should now be able to click on a component on the PCB, and it's married it up with the input over here. So that looks right. It's that capacitor, it's in the power sheet, etc. So that's, it looks like everything is working nicely. That's our one that we created on the input of the quad buffer 1, and this one should be the input of quad buffer 2. Great. All right, so I'm happy that we've got a properly synchronized schematic and PCB. So now we want to focus on the PCB a little bit more specifically. So I guess if I go back into the three-dimensional view, the first thing to notice, we can't see any tracks or connections physically between any of the stuff. And the other more obvious thing to notice is that everything's on the one side of the board, which might not be that useful because we're plugging in jacks here, and then there's suddenly a power that would be on the front of the unit. So we're going to have to, and despite all of that, this is probably not the most efficient layout for a module. I want to get this thing as kind of thin as we can get it, because on Eurorack we're measuring the width of modules in units of horizontal pitch, or HP, which is, if I'm not mistaken, 5.08 millimeters per HP. So what we want to do is lay this out, and probably starting with the controls, because that's the side of the whole thing that the user is going to interact with, and that needs to be laid out ergonomically. So, all right. So I'll leave this open on the side so we can kind of see what's happening as we're going along here. All right. So first off, I'm just going to move. These things are kind of grouped by roughly by the function. So we've kind of got power over here, apart from this wonderful input jack. So I'm not going to, I'll arrange these jacks in a moment. I've just noticed something else. They're all labeled audio jack to switch T, which is not very helpful if we're wanting to know what these things are, we're going to have to look at the actual reference numbers, and that's no good for our sanity. So let's just go back to the schematic quickly and give these things more useful names. So this one is input A. This one is out A1, first output. Let's just copy that text. Then we've got out A2, out A3. And note, I'm not changing the references. I'm just changing the label of the part. And actually, it might be useful to have Jack in front of the name, just so that when we're looking at it in our list of things, we can see quite clearly that it's a Jack. All right. So I'm going to carry on with that. Jack underscore. So we're dealing with the A channel, and then over here, I'm going to change this LED to LED underscore. I'm just going to make it A, right? So it's the A channel, the quad buffer A, and then we'll look at quad buffer B and do the same thing. So it's Jack underscore input A, Jack underscore out A, whoopsie, you probably spotted what I did wrong. B1, let's just go change that again to input B so that we can see the difference. So we've got Jack output B1, just copy that text, paste B2, B3, and then I just did LED A, so this can just be LED B. And let's just do this by directional to pin. I'm just going to put that there because once again, when we're looking at our list and we look at the LED, we're going to think that's just a standard LED unless we notate something here. So that's why I've done that. And let me just stay in here and copy the same onto that one. Okay. Good. So save that, go back to the PCB and synchronize again. And now we can, if I just, we can see this is like input A, out A1, out A2. Otherwise, we end up placing our jacks and they're the wrong jack for the wrong thing. So just kind of useful for that. So A1, A2, A3. Great. Input B. Let me just change this. The selection filter down here is kind of useful because I can say nothing. So now when I try and select anything, I can't. And I'm going to say just footprints. So now I can't drag text. I can only drag an entire footprint. Right. So Jack input B, output B1, B2, B3. Great. Those are our two channels. Let's move this together with the power stuff over there. All right. And then we want those LEDs because it's kind of part of the user interface. This is LED A, so it's part of this lot. And LED B is part of this lot. Great. So what I'm going to do next, I think so probably what I normally do is I start off by creating a board outline because that gives us a sense of placement, like how, how closely they need to be put together, or how much space we've got to work with. Now, what you'll notice on the right, all of these are the layers of the PCB. So we've got front copper, front adhesive, back adhesive, front paste, back paste, silkscreen, mask, and so on. And then everything from here, user drawings down, have kind of specific notational functions. So, for example, a courtyard is this pink thing around the component, which gives you a sense of maybe you shouldn't collide those courtyards. You see how it goes red when I move it like that. So we don't want overlaps typically like that. There are exceptions, of course, when we get into the deep layout, and we'll see that in a moment. All right. So if I wanted to, for example, get rid of looking at all these courtyards, I could just take off the front courtyards, back courtyards, front and back fab. Those are the fabrication labels. So like these labels and so on. So you can kind of filter out what you're looking at, right? And you'll see in a bit why when that becomes important, so that you don't lose your mind. Okay. Right. So we're interested actually in the edge cuts. The edge cuts are the layer that's going to help us understand or design the board outline. So I'm going to select the layer edge cuts here. Now that's the layer that we're working in. So if I draw anything like a rectangle, that rectangle is on the edge cuts layer. And in fact, we can see what the impact of what that just did. Great. We've got that board with some floating components all around it. All right. Now, obviously, we want to make this board the right dimensions. And there's a thing that I use. Let me just load my browser. What did that just? Yes. Okay. And it's the Dupfer. It's like a Dupfer reference for design and sizing and so on. I've always just used this chart to help me size modules. So it's giving you a comparison of how many HP the module is. That's the width, and what that means in actual calculated width. So remember, I said it was 5.08 millimeters per HP. So obviously, if it's 8 HP, it's 8 times 5.08, which gives you that number. But then there's the actual module width, and this is the width of the faceplate of the module, right? So imagine this is the faceplate. So the module width is what we're after, edge to edge. We can see that the module height, the faceplate height, is 128.5 millimeters across the entire height. So we've got the y-axis, 128.5, and we need to determine what is the width. So 6 HP is not too bad. 4 HP would be better for such a simple module. We don't want to take up too much space in the rack. So the actual module width is 20 millimeters wide. Okay. So I'm just going to kind of put that over there while we look at this. Maybe just do this. All right. Now I want to select this block that I added, and I can't. And guess why? Because it's not a footprint. So I'm going to take that off and select graphics, because that's what this thing is. It's a graphics block. Now, a couple of ways to do this. I could either just guess and kind of move it and hope for the best, but probably better to actually type in the size. So if I have it selected and I press E to edit, I want to be, so it's giving me the the start point on the x-axis, which would be the left of the module, and the end point. And again, I don't like having to calculate what is going on there. So I'm going to change this to say, give me the center point, that point, x and y, and give me the size. Right, so the height of the module, or this is now the height of the board that is sitting behind the faceplate, right? So the height of this, I normally choose 100 millimeters, and there's a reason for that. If I go to 101 millimeters, when I send this in for PCB manufacture, it's going to cost a whole lot more. Crazy, I know, but it's because of how the boards are sized and so on. So suddenly you've got to go onto a bigger sized board to cut from, and it costs more. So wherever possible, I try to keep the height of the module 100, use the maximum available within that price range. And the width of the module, we said, was 20 millimeters for a 4 HP module. So that's the faceplate. We probably want to shave off just a smidge for the PCB behind, so that when we, if we've got a tightly packed rack with exactly 4 HP of space left in it, as we slide the module into the rack, we probably don't want it crashing and scraping other modules. So I'm going to make this 19 millimeters wide. Okay. Everything else we can leave the same. We can see it's on the edge cuts layer. So let me do that. Right, so that's looking more like a Eurorack PCB. If for reference, I wanted to just see what the size of the faceplate would look like in comparison, I could just draw another block. Maybe this time let's just use user comments layer for this. And I'll draw another block. Place it here, press escape. Okay, so select it, edit it, change its height to, and we had it here, right? To 128.5. 128.5. By the way, make sure you're in millimeters and not imperial system, otherwise things are going to be really wrong. And 20 millimeters wide, right? So let's see what that looks like. So that's what the faceplate would look like over it. So you can see there's a little bit of a gap between the edges of the PCB and the faceplate, and there's a gap on the top and the bottom. Now, that gap on the top and the bottom, let me just move these things. See, so that all this other stuff is out the way. That gap on the top and the bottom, of course, it's gonna be mounted onto a rail on the top and on the bottom when it goes into your rack. So you literally cannot make this board that much longer, or it's going to crash into those rails. Yeah, so that's we could make it. I think I've made boards successfully up to about 110 millimeters, and that's really cutting it fine, depending on the kinds of rails you've got and so on. So even if we could make this a little taller to squeeze more components onto it, it's not really going to help us that much, and it's going to cost a whole lot more. So yeah, those are the reasons. Okay, so I'm going to move this out the way, and we're going to focus on this board and how to populate it. So I'm going to start with the jacks. Of course, I need to select, I'm just going to say all items. So let me say these 4 jacks, this is, whoopsie, and this LED, they are all part of the second channel, right? And these are all part of the first channel. I'm going to move the power further away. If this rat's nest is bugging you, you can turn it off. And what these are is it's showing that there's connections that need to be made on the copper layers between these points, right? But we're not going there yet. We first want to lay the controls and so on out. So I'm going to just turn off the rat's nest, which is on the left here. And now we don't have all that noise while we're laying out. Okay, I'm going to focus purely on footprints. So we probably, obviously we can't fit it on the board like this. So I'm going to suggest that our input is somewhere at the top. This is channel 1, channel A, as we called it. And I'm not worrying too much about getting this precise. I'm just putting them close enough. But what we can already see is there is not going to be enough space on this board to lay out the next channel. It's going to go off the edge of the board. So what could we do? I would rotate these things. So R to rotate, and just place them like that. R. And now we've got a lot more. Shift R does the opposite direction, rotation direction. So now we've got a lot more vertical space, right? So that's kind of necessary. Maybe we want the LED around about there. I'm then going to do the same with all of these. Rotate, so there's the input jack, the output number 1, output number 2, output number 3. And of course we can go right to the edge of the board on this slot, right? Okay, and we probably want that indicator LED somewhere around here. Okay, so this gives us, if we now go and look back, just going to hide this again. If we now go and look back here, it looks like we're getting closer to what the actual user interface is going to be. I mean, for sure, these aren't perfectly aligned and so on, but that's giving us a good idea of what the module is going to be. We're going to plug a cable into the input. It's going to start lighting up when there's signal in there, and then we can pull that signal out of any of those 3 jacks. Right, and if we didn't plug something in here, then we can pull the same signal coming in here out of any of these 3 jacks. Cool. So that's starting to feel pretty good. Now, we've got, of course, a bunch of other components to ultimately get in here. Right, so we've got all the input A, the mult channel A components and mult channel B components over here, which somehow need to fit. And if we have a look, there's a whole lot of stuff there. And then we've got this chunky IDC connector. Probably we're going to have to rotate that as well. But there's something else. The board has a backside, right, so to speak. And so we could take these components and say, I want to flip this to the back of the board. So I press F, and now you'll see it's got this blue courtyard instead of the pink courtyard. So blue stuff is on the back, red stuff is on the front, or red or pink, right? So if I have a look now, you can see, it's the other way around. So I could move that, could move it there, but now we see it's actually sticking off the edge, so that's not going to work, right? It's wider than 19 millimeters. So it's going to have to go like this. And that means we can see already it's colliding or pretty close to colliding with the jack there. Probably move it a little more. And that's less of a problem than on the other side, where it's very close to colliding with those, with these pins of the jack socket. And in this case, I think it has collided. No, it actually does just fit in there. So this could be one of those examples where we say, well, we're okay with it overlapping, even though it's complaining that it's hitting other components. We can physically see that it's, we could solder that, right, without melting the output, and that's not actually colliding. So while it's warning us, we can just ignore the warning. Of course, we could also spend a bit of time and say, well, how else could we lay this out so that it isn't so constrained? Okay, so I think what I'm going to do is, because we've got two of exactly the same thing, I want to lay out one well. So I'm going to take all these components, just move them off to the side here a little bit. And yeah, so then say, select all of those and right click on the top one and say align distribute. We want to align to the horizontal center. So it's between left and right. I want to get them aligned. So now it's done that. Nice. The next thing we could do is say distribute vertically by the centers. And because they're all exactly the same component, they're not different sizes and stuff, I would use by centers. If they were, a big one, small one, big one, small one, I could say with even gaps. So I'll just use with the centers. And now it's perfectly spaced them and they're perfectly aligned with one another. There is still quite a bit of space between them. If we look on over here, there's quite a big gap. We don't need that. So if we're really pressed for space, we can actually just push them together a little tighter. And one way to do that would be to move this up a little bit and then redistribute them. I'll show you how to do this. Problem is, if I move it, I could accidentally now move it out of alignment with the other ones, right? So I'm going to undo that. And I'm going to select it, press M to move it, and then I'm going to press up arrow on the keyboard. And now with the mouse, it's locked. I can't move it left and right. It's going to only move up and down. So let's move it about there and see what this does if I realign redistribute all of these by center. Okay, so now it's overlapped the courtyards, but I treat that as a warning. I check the physical properties, and that's pretty good, I would say. All right, so then let's see. So one option is we could put these right up to the top, like so, and decide what to do with this LED. So again, the LED, as long as it doesn't collide physically or have the pins collide, we're good to go. Right, so that would be one approach. Remembering that we've still got, if I just pull this guy over here, we've still got plenty of space on the front of the panel before we hit into the rail. So yeah, we can really have things, if we wanted to, coming off the board at the top. It wouldn't be an issue really. Okay, so the other thing I'm noticing is that there's a ground pin here and a ground pin on that side, and I probably would just get those closer together. So I'm going to rotate this until it looks more like that. And now, yeah, So that'll be our indicator for input coming in here and obviously going out to all those outputs. Now notice what we've got. We've got a whole lot more space to lay that out if we want it to be like that, right? Yeah, so that's not too bad. Just means there's on the front faceplate there'll be this blank space, but that's not necessarily a bad thing. When we design the actual faceplate, we could put graphics there or do something like that. Okay, so now I've laid out the one. I want the other one to be the same, so I'm going to drag all these components over here and just move them a bit lower than these ones. So first off, I'm going to say align these to the horizontal center. So now they're aligned. And now I'm going to select this one and then shift select this one and say right click, align to top. And it generally aligns to the one that you last, that you right clicked on to align. I mean, if I wanted to align this one to the top of that one, I would do it this way around and go align to top, and it moves that one down, right? So I don't want that. I want to align this one to this one, top, align this one to this one, top, and this one to this one, top. Okay, so now they are precisely the same amount apart. The only thing is that this needs to come and be aligned also to that one. And I notice I need to turn this one around as well, like I did the other one for those grounds. One. Okay, it doesn't matter. Let's just align it, align to top. And now we can also see that, yeah, this one's sticking out further than that one is. So what I'm going to do is bring the stuff up here. Actually, I can just pull it to roughly where it's going to go, right? So roughly to there. And then I can say align all of these. I'm just going to move them across. Oops. Just going to move them across so they're obviously very out of whack. And then I'm going to select them all with shift clicking. And then I'm going to say align those to this one. So right click, align, let's say align left. Okay, so now they should be in a straight stripe, which they are. And now I can say also align this one to this one, left. Okay, so now we've got two little banks of input outputs, and the LED. And yeah, that's a pretty simple user interface. The only other thing I would consider is the hole, is the, it's just dark, come here. So is the actual, in fact, I'm going to do that and just get us in out of perspective mode. Is the center of the hole aligned with the center of the board? And it doesn't look like it is, right? So the way that I would do this, I would just go, okay, we're already on user comments. So let me just draw a straight line like this. Okay, on the user comments. And now if I align that to the center of this, this board, so I can select it, select the board, the edge cuts, and align to horizontal center. So that is now dead center. So, oh, just me, or is that sticking off the edge? It does feel like it's, yeah, it's sticking off the edge ever so slightly. So let me just press M, start moving up on the keyboard, and now I can get that. Yeah, I'm happier with that. A little bit of overlap there. Okay, so I'm going to take all of these items and I'm just going to zoom in here. I'm going to press M and left arrow and just move it until I would say that's as close as damn it to the center of the jack. So I'm going to hit enter, pins it down. We've shifted it all over slightly, so now it's really in the center of the board. Question is whether that's that's not so great. So let's move both of these LEDs. Let's move both of these LEDs. See if we can get it in enough so that looks better. And just make sure it's not actually, yeah, it's not colliding. Wow. It's not colliding with the pins or anything like that. It's, again, it's fine. We've got that physical blank space, so we can use it. Okay. And the same should be true for this one. Yeah, I mean, you can see the silkscreen, those little white lines that will be printed onto the PCB ultimately is getting overlapping the pad, but that's okay. We'll sort all of that stuff out later. All right, so I'm going to save this because now we've got our controls laid out and at least the biggest component laid out so that it's not colliding with anything. Great. Okay, so that's the easy part. Now for the fun part, because if I put that rat's nest back, we've got to, you know, I could take these components and randomly put them wherever I want on the board, but that's probably not a good strategy because we don't want, we need to kind of untangle this rat's nest as best we can so that we don't have too many overlapping tracks and things like that. So what I'm going to do is, I think by default, I'm going to push all of this, flip it all onto the back of the board, and then we can, you know, there's a bunch of space here we could use. There's stuff on the edges here we could use if we need it. But for now, if I put it on the back of the board and we go, well, this is all the power stuff, right? So probably it makes sense to be close to the power connector, right? And in fact, what we can see if we zoom in here, so here's a neat little trick. So I can see that this is the ferrite bead, right? In fact, let me also, no, it's fine. So remember, blue is on the back of the board. Red is, well, in this case, it's going all the way through the board, but it also means that there's copper on the front of the board here, right? So there's red and blue, front and back. So yeah, if I want to place this component, as I'm moving it, if you look closely at this line, there's a line that's saying it needs to be connected to that pin, right? So I probably want to get it as close to that pin as I can. Now, if I'm doing this, let's have a look at the back of the board and see what we're actually, see what we're actually dealing with, right? So I've got this ferrite bead, and I'm moving it. And if I move it closer here, it collides. It's going to be really hard to solder that or to get it off if I placed it there. But I want to get it as close as I can to that part. So I'm actually going to bring it here and I'm going to flip it back onto the front of the board. And let's have a look. Aha, easy peasy. Tons of space, right? So I've done that. I can also see that there's a line coming down from this pad all the way down over here, I think. And that's a diode, right? I can see that it's needs to be connected to there. So I'm probably going to flip that to the front as well. So I could just put it like that. That's pretty neat. And all of this is on the minus 12 volt rail. Pin 1 of the 1 and 2 of the Eurorack connector is minus 12 volts coming in. So it's coming in through a ferrite bead and hitting a diode. If we go back to our schematic, we would see that I've selected that diode. That's the diode there. So there's pin 1, 2 of the connector, 1 and 2 of the connector going through the ferrite bead into the diode. Right, so it looks like we've got things going here. Now, you might be looking at all of this and going, holy cow, there's a lot of noise when I'm looking at this, and for sure there is. What I'm going to do is I'm going to turn off some of the layers so that we get a less cluttered view. So I'm going to turn off, we don't need the user comments anymore for this line. We've made use of that line already. I'm just going to leave it there, but I'll turn it off. I'm going to turn off the fab layers. And now it's looking a lot less horrific. I'm going to turn off the courtyards as well because whatever. And I think I'm going to turn off these little pink pluses. It's the anchor point of like this footprint, anchor point of footprint. So I don't need to see those. That's under this object section. I'm just going to turn off anchors. Yeah. Okay. So I think that's looking a little bit easier to see what's going on. Now, if you remember from the schematic, if I go to the power, there's on both sides, there's a ferrite bead, diode, and then a bypass cap and a filtering, well, not a filtering cap, essentially a reservoir over here, right? So, in other words, so we've placed this one and this one. I need to find the next two and probably make a similar pattern on the other side of this jack. So a neat way to do this is just to select, shift select over here, then click back on the PCB, and then I hit M to move, and those components just are attached to the mouse. So I can, even if they're distributed all over the place, which sometimes they are, it's a useful way to find them. So we're going to want something probably like that. I'm going to flip these onto the front of the board again, select them and move them over here. And plus 12 is coming out here, minus 12 is coming out there. That seems relatively symmetrical. I could move these back a little bit. Something like that. Great. And then we've got the electrolytic cap and the MLCC ceramic cap, right? So these are the two for the minus 12 volt rail. So I select them here, click on this window, hit M, and now I've got those two. So this is the minus 12 volts. Over here, this is the plus 12 volts over here. And yeah, so what do I want to do? I could put these on the front. I'm also just wondering about these ICs because they're quite chunky. And I don't know that there's going to be enough space to get them between the pins. Not really. Not really. So these might have to come. Let's just have a look at the output again. So I put that on that side. There's not a lot of space around it physically, but it's not bad. If I flipped it onto the other side of the board, yeah, I mean, potentially there's a little bit more space, especially if I've got to put one there and another one there-ish. Yeah. So there's probably a little bit more space on the front of the board because we don't have that whole shrouded header taking up physical space. So I'm just going to plonk them there for the time being. Let's see what we can do with this power now. So we want plus 12 volts was at the top here, and minus 12 volts is at the bottom here. So what I could do, it's like there's quite a lot of space over here. So maybe what I should do is move it here-ish. Let's see where that's gone. Yeah, it's there, but yeah, so it says it's kind of colliding with that shroud. And of course, on this side, it's potentially colliding with that jack pin over there. So I'm just going to move it with the keys just a little bit. In fact, I've got another cunning plan that cannot fail. I'm going to move it there-ish. I guess the question is, are these things equidistant? You know what I'm going to do? I'm going to take this, 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 and this. So those three things, just to make sure that this is dead center, and I'm going to distribute them vertically by their centers is fine. Yeah, so it wouldn't have moved the outer two ones, just the middle one. And it looked like it was pretty centered. Right, there are other things we can do here to make this just right. What would happen if I brought this onto the other side? That's not colliding with a jack, is it? Yeah. Okay, so back onto the back. Oh, everything's very tight. I think what I've done in the past is actually just put them here-ish. So let me just take one and slap it in the middle of that. It's kind of on the other side of the board, right? Slap it there. I could even do something like that. So we've got minus 12 and minus 12. By the way, another useful hint is if I press the back tick on your keyboard, it's like a single backwards apostrophe. When I'm hovered over, if I've got pads selected, so I could select a single pad if I wanted to. If I hover over pad and I select that tick mark, it shows me all the other pads that should need to be connected to that net, right? So I can start getting a feel for the layout as well. And because this is minus 12, that's minus 12, and this is ground, and that's ground. So we could actually put those, they're on opposite sides of the board, but still minus 12 and minus 12 are very close, and ground are very close. So that could be useful for us. And then where was this other capacitor? Over here, we've got this one. And this also needs to be pretty close to at least to this minus 12 over here. So I'm going to just put it on that side for now. Okay. Then we need to sort out the plus 12 odd rail. And we could do something similar. Just for now, we can change anything as we go, but I'm going to start off with a strategy. So, plus 12. See, there's the plus 12 over there. I mean, frankly, I could just put it. Yeah, I've just noticed something. I really want this minus 12 and this minus these ones. This is where the signal's coming in. I want those to be close. So I'm going to turn that around. Let's just jam it over there. Why not? And grab this plus 12 and just stick it over here for now. Okay, so now theoretically we've got some power there. We've got the ferrite bead and the diodes on the other side of the board, and we've got the capacitors on this side. Right. Then we've got, what are all these things? This is where things start getting interesting, right? So I'm going to go back to the schematic and say, what are you? And that is on our on one of our buffers. It's on the second buffer, so channel A. I can see that because there's the first buffer, there's buffer 1. So these two are bypass caps that are connecting on the plus and minus 12 volt rails of the TLO74 chip, so the chip that's got all these op amps in it. So I'm going to grab those and move them, and we can actually see here how it's kind of latching on. And now when adding a bypass cap, you've got to get it as close as you can. I'm going to bring it onto the front layer, so it's right there at the chip. And the same with the other one. Let's move that close to that 12 volt pin. I know it's complaining, and like really, it's not the end of the world. It's going into the space under the LED. I mean, whoopee-doo. Okay, so I'm going to put it like that. Right, so that's the one buffer. Let's get the other one. So the other buffer, those same doodads. Right. So plus 12 is up there. Again, I could see it if I did this. So plus 12. Bring that onto the front. Aha, yes. It's moaning about this jack. Let's just again look at that in 3D. So we could see it in green there. I'm not worried about that at all. So that's nice. It's close to the 12 volt here, and it's not actually overlapping the physical jack. Bring this to the front, flip it to the front, bring it in here, close, like sort of hit the chip and then go back until it is all good. All right. Oops, didn't want to do that. Okay. So it feels like we're getting somewhere. Of course, nothing's wired up yet, but at least we're getting the placements so that the traces should be relatively short. So let's have a look at these. I'm guessing, remember if we look on the schematic, remember these resistors that we moved into the little buffer sub-circuit. That's what those 4 resistors are all about. So if I grab all of those, this is for buffer channel A, and I come back here. So these ones are going to be over here, and they are essentially for the LED, and there's probably this one as well. Yeah. They're for the input, each of the outputs, and the LED. So great. And these ones, same dealio, but for this side, for channel B. So let's lay out channel A. Now, yeah, so I'm actually going to have a look at the schematic. Okay, so this one, that one is our input. So let's move it to the input jack. Remember, it's on the back, it's blue, so, and the jack is on the front, so we can really get it nice and close in there, so that's all good. So that's the input. Then this is out. Oh, C, okay, yes. So it's out A, out B, out C, out D. So this one is out A. So that's the input. Yeah, quad buffer out A. Cool. I'm just going to put it like that. Why is it also connecting to input? Is that correct? Ah, it's connecting to input like that. So it is correct. Okay. And then we want out B. In fact, I could probably see it. Here we go. That's out D, out C, and out, whoa, out, way out, out B. Okay. So let's do out B. Something like that. This is out C. And if you recall, out D was for the LED. So I'm just going to, yeah, just going to do it like that. Perfect. All right, so then input, what is this? This is out D. It feels like these are exactly the wrong way around. Yeah, so this is input ground. So that's for the input. Then we've got out A. I'm actually going to move this other one. This one is out B. Out C. And always just watch that the line is actually going where, you know, if I was pulling it here, I'd see the lines far away to that other pin. So that looks good. And the LED out D, yes. So could even squeezerize it in there. Great. So if we now look at the board, I'm just going to focus on that for a moment. So now we've got all the components on the board, and they're pretty close to exactly where they need to be. So we're very close, one would think. Let's put that in perspective mode again. We're very close, one would think. Yes. Now we go through the interesting part of adding all the wires. There's something, however, let me just save. Always a good idea to save once in a while. There is something, however, I like to do, especially with the PCBs that are behind the scenes. In other words, not on the front panels. If I select this thing, I just want to go back onto edge cuts. If I select this and I right click it, I can go create shape modification, yes, fillet lines. And I want, let's say, a 3mm fillet. So 3mm from the edge, start creating a rounded corner, in other words. And that feels a little bit too severe. I mean, maybe not that bad, but a little bit hectic. It's also chopping a bit of that LED pin off. So let's just undo that. Edit, not edit. Fillet lines. Let's go 1.5mm. Yeah, that's a little more subtle. Just so that, yeah, it just feels nicer when you're working with it. You don't get these jagged corners. All right, looks a little bit cooler as well, I think. So, nice. Okay, so now I'm going to take, I'm just going to hide this rat's nest. Yeah, let's do that. Now I'm just going to, I don't want to accidentally move footprints or anything else, but I am going to be working with zones now and graphics. So what I want to do, at the moment, there's absolutely no copper on this board apart from where you see the pins. There's no copper. So the first thing I do with this is create what's called a zone. So I'll show you just an example. I could take, so it's this thing here. It says draw filled zone. Sorry, before I do that, you've got to choose a front or back copper. Otherwise, it's not going to do what we want. So if I just click, it asks, what do you want? Front copper, back copper, both? What do you want? And then it also talks about what net do you want to connect it to. So essentially what I want to do is I want to fill the front copper of the board, and I want to make that plus 12 volts. And I want to fill the back copper of the board and make that ground. It's really important to do this, especially the ground plane, because this helps reduce RF and various other issues. So I'm going to start with a back copper, and I'm going to say choose the net ground. I'm just going to call it, let's just call it ground plane. So we've got it there. I also know that I'm going to want some filleted corner smoothing. Let's just say 0.2 millimeter fillets. And I want a clearance. We'll see what this is. And actually, I'm going to leave it. I'm going to leave it for now, and we'll come back to this. Okay. So I'm just going to create a straight ground plane on the back copper. Solid fill always. Okay, that sounds wonderful. Do it. Okay, so now the problem is I've got this flipping cursor and it's like out way away from the board. So let me just try something just for giggles. Yeah, I don't like that at all. So let me just nuke that. I'm going to come back here, start again. I just want to draw your attention to something else. At the bottom here, you see it says grid 0.05 millimeters. That's quite small. So I know that if I want to, I want to make this grid bigger. So if I just press Shift N, it changes that value. Now the grid's on 1 millimeter. And for whatever reason, I must have set it. Oh, here we go. I can select the grid. And now I can see that grid, right? So what might make things a little bit easier is if I just selection filter everything, copy, not copy, but let's drag this stuff and get it aligned with. You can see the grid is like broken into sub things. So it's not quite aligned on the left and it's not quite aligned on the top. So I'm going to reduce this, not Shift N, N. And I'm going to try and move this all just with a keyboard. It's still too big. I'm going to N again. And again, and again, and again. Ah, that seems to have matched up. And that. Right. Okay, so, and then I can just, let me just get the grid. I don't know. Well, let's go with 0.1 millimeters and then just hide it again. Okay. So what I'm wanting to do is draw a zone. That's what we're trying to do. So if I hover over this line and I kind of go up and I get it aligned with this side, about there, and I hit the first point. Right, so we want it on the back copper and we want it on the ground plane. Just give it a name if you feel like it. Ground plane. Hit OK. Now your cursor is dragging this line behind it. So now again, I want to line it up there. Doesn't actually matter. It can stick out the side of the board and stuff. It really doesn't matter, but I'm OCD like that. Okay. And again, we want to just line it up. Perfect. And just drag, and then again, we're lining it up there. Click. And now moving up here to the top. And this last little piece is important. Get it on there, and that finishes it. All right, so now you'll see this, this blue hatching around the edges. That's showing that we've got a zone. And if I've got everything else unselected and I say zones, I can now theoretically, yes, select that zone. If I hit E to edit, I can see it's on the back copper, on the ground, and with these settings, right? Now, I want to fill that zone right? I want it to actually fill with copper because at the moment it hasn't. And we can kind of see that if I look on the back of the board. I don't see anything under the front mask. Under the back mask. It's just copper and board. So if I come into the PCB again and I press B, that does a copper fill. And now you can see what it's done. It's filled this entire back copper, the blue, across the board. If I now switch onto here, I can see that's all filled in, right? It's traced around things that it's not connected to, and it's traced onto pads that it is connected to. The beauty of this is all of the pads that are ground pads that are on the back of the board are now connected all together, which is exactly what we want, right? So that's kind of cool. If we have a look at a ground pad over here on the back of the board, it's connected. If we look at a ground pad on the front of the board, it's not connected, right? So we'll have to figure that out in a little bit. But first, so that's nice. We've got a ground plane on the back. I want on the front copper, I want the plus 12 volt rail, just so that we can distribute the power across there easily. So I'm going to select the zone. Remember to have that ticked. Select this zone and Command D on Mac, or probably Control D on Nintendo, and that will give you a perfect duplicate. Do not bump your mouse. Hit enter again. Okay, so now you've got two zones. If I actually click over here, you'll see it's got which one do you want? And I don't care because they're both exactly the same. So I'm just going to select one of them and hit E to edit. Flip it over to the front copper and select the plus 12 net and just call this plus 12 volts. Right. Hit OK. Hit B. And now it's filled the front copper as well. If I just take off the front mask, we can see that as well. So I guess anything that's connected to plus 12, like we're seeing, let me just kill the silk screen. So we're seeing here a pad that's connected to the plus 12, another one that's trying to be connected, another one that's being connected, and so on. So it's connected all the plus 12 stuff on the front of the board. All right, so what we want to do now is actually start connecting up all the things that aren't connected. And to see this, I'm going to show the roots. There's another little trick. If I press H, it dims the back layer. And if I press V, it brings the back layer forward and dims the front layer. So V just toggles between the two layers, so you can clearly see the copper of the back and the front. So I always start with power because it's kind of the most important thing. If your power is wrong, nothing's going to work properly. So we can see here there's something else I need to do. I like to make the power traces or tracks on the board thicker than all the other tracks. And so we've got to look at the nets. So this is currently showing if I press the backtick key, I'm actually going to select tracks, pads, and zones. Don't need zones. Tracks, pads, and vias. All right, so if I now hover over this pad and I hit tick, I can see that's a net. It's the input A net. So in other words, it's where the jack is coming in. The jack's coming in here. It's going to a 1 mega ohm resistor to ground, and it's going out all over here, right? So I can now really isolate that out, but I'm more interested right now in the power. And we know the power is coming in minus 12 volts from pin 1 over here. So that's minus 12 volts. If I hit V again, yeah, minus 12 volts isn't like connected to either one of the planes. And that's probably a good thing. If I hit on the other side, plus 12 volts, tick, I should see. Oh, does this need to be selected? Why is plus 12? Oh, that's not plus 12 volts yet. It's the input. It's on a net called J9 pin 10, going to there, then going through the ferret, going through the diode, and then there's our 12 volt rail. So that now we can see is all over the board. Okay, the point is I want to make sure that all of these power related traces are thicker when I draw them in. So if I go to net classes, remember it was up here, nets, I can see all the nets on the board. Not very many on this board, so that's quite neat. I could then say, right, so there's the default trace width and clearance and via size and holes and all sorts of stuff. I'm wanting to add another net class, and I want to call it power. I'm happy with the same clearance. This is the amount. So if you see actually on here, that's the clearance. It's 0.2 millimeters away from the next another net, right? But the track width, I want to make, let's say, at least 0.5 millimeters. The via size, the track width, I think needs to be about 40% larger at least. No, the hole needs to be 40% larger. So let's see, the hole then would need to be 0.7 millimeters. The via size, no. Sorry. let's make this 0.8 and make this 0.5. It wants to be 0.6, right? Then there's micro vias and there's, yeah, so I'm just going to add a little bit to these ones, 0.4, 0.2, maybe 0.5. And these ones I'm going to just make the same. Okay. So I've created just another class of nets, but I haven't added any nets into that class. So by default, all of the nets, when I add tracks, are going to use the default settings. So I'm going to want to come down here to net class assignments and add on the power class to pull that stuff. And now we need some patterns. So the obvious ones would be plus, in fact, I could just say 12 volts star 12 volts. So any net that is, so the plus and 12 volt nets are now going to use those parameters. I also need to include this net. So it's, I guess it's jumper 9, which is our connector, J9. So I could say net dash J9 star. So now we get, it selects J9 pin 1 and pin 10. So this is J9 pin 10. I can't move around, but pin 1 obviously is on the bottom. And also I need to, there's a little one here. So that's net, that's diode 3. So net dash D3 A. So that one will now be in there. And I need to see a little further down here. So that's J9 pin 1 we've got already. So it's D4 cathode, D4K is that one. So add net-D4. Well, it's everything on that diode, so let's just do that. Also select power. Right, is there anything else I'm missing? No, I think that's it. Those are all the power things. Now, kind of a neat thing, if I've got these classes defined, I can also hide all the default ones, and this should just show the power. And why is it not showing the power? Okay. For some reason I select and select again. Okay, so now we've just got power in those little lines. I'm going to press H to make it seriously obvious what's going on. So yeah, a bunch of things we need to connect, and as it happens, because we placed all our power circuitry over here, it's limited to this little space on the board. Okay, H. So let's draw some tracks. I'm going to hit X to start a track and draw it. And what you can see is the thickness of that track. Let's just draw any other track like input A. You see the difference in thickness, power, everything else, right? And that's because of our net classes. Then I want to connect that up. So X again, X again. And by the way, I am on the front copper. I could have, if I'd wanted to, let's just delete all that. I could have switched to the back copper and drawn on the back copper. However, when I get over here, it's not connecting. You see there's still a line there. And that's because the part is on the front copper. So for now, I'm going to keep it simple. I'm going to stick to the front copper for these components. But now here we're going to hit a problem. Right. So I can't just draw it like that. And this is what vias are for. So I could drop. So I've got two approaches here. I could draw a trace from that plus 12 volts. And I could put a via down, drop that, and now it switches to the back and I can connect it. So that's kind of cool. But there's something that's not necessary here, and that's this line. So if I just show you why. So if I press B to refill the copper again, calculate the copper, and then I delete this one, and it's not obvious. If I move it over here, I think it's because my via size is a bit not great. The point is we've got plus 12 volts is this all of this red area here. So if I just connect to that, so I'm just going to edit this net class, sorry. It's like the hole is too big. Wow. Yeah. So the power, let's just make this 0.4 millimeter. So that should give us a bit of a bigger, just delete that. Switch to the back copper with V. Hit U to select that whole track. Try again. V. That's looking better. And still, I'm not seeing it connect to the front copper. Just move it out of the way of all this other stuff. Oh, I'm an idiot. It is connected to the front copper. That's the front copper of the via that's actually connecting it. Okay, so if I just place a small trace out of there and hit B, so now there's no line between those 12 volts, no rat's nest line like we have here. So I'm going to do the same thing here on this side. So go to the back copper. I'm just going to come off over here, hit V, and now that's also connected to 12 volts. Great. What you're going to notice if you zoom in over here, it says we've got 56 unrouted. We want to get that number to 0, right? So we've made a little headway, but we've got some ways to go. All right. So here we've got -12 to -12. I'll just press B every time. Now, to refill the copper. Now, there's a frustration I have, and it's because of the clearance, the zone clearance. This gap over here it's huge, and we don't need such a clearance on a circuit that really doesn't pump a lot of power. So I'm going to go to the zone. I'm going to edit the zone, and I'm going to change the clearance to 0.2 and the relief gap to 0.2. And then refill. Okay. So now there's a lot more. If I undo again, you see it wasn't filling in this gap here because there was too much clearance requirement on the zone. Now I've made it, better. So more things are getting connected, which is a lot better. Okay. Let's see, where else? We've got, just want to check if I just get rid of all of those, just look at +12, and I go H to hide the noise. It looks to me like there are no more +12 rat's nest lines. So 12 volts is sorted for now. So now if I look at -12 volts, I can see there are a bunch of things to connect. So let's check it out. -12 volts, stay on the front copper, drag a line. We've got a problem there because that's on the back copper. Drop a via with V, carry on the back copper, and it's connected. Similar story over here. Drop a via, connect it. These two can just connect direct. And yeah, we can see there's a net that needs to connect. So you could connect it like that, and we get rid of that. It's just showing the shortest path, right? So I guess what we want here, something like that. Looks all right. Fine. Okay, so now it's really just that one. And now guess what? If I pull a line here, it's not going to go down there nicely because it's too fat to fit through there. So what I'm going to do, and also if I show the back layer, there's the stuff in the way, at least on the back layer. So I could run a line across, And I could just run it down, but I want to switch layers at this point and run it like that. Great. So our plus 12 is connected. Very nice. Which means actually that all our power apart from ground is connected. So ground is mostly connected, but there are components on the front copper that are supposed to be ground and they aren't connected. So if there's things close together like this, I'm just going to connect them on the front. Hey, forgot about the net class for ground. Right, that line, there we go. Nice fat line. Another nice fat line. If I hit B now, okay, good. Another nice fat line. Whoopsie. Okay. Then all of this stuff needs to connect to ground. So one way to do it would just be to hit X, V for a via, and by default, it's connecting now to that ground plane. So that's pretty cool. By the way, something to avoid would be doing that. We don't want acute angles like that. It can cause noise in the circuit. So best just, and undesired effects. Not so much an issue with analog, but for sure with digital, where you've got high frequency stuff going, it can cause problems. All right, so we've got all of those things now connected to ground. Let me just go back here. So we've got ground. We've got ground. We've got ground. That's all pretty neat. So all of that's now connected to ground. This one is saying that's not connected to ground, but again, I could just there's must be a pad under there. Oh, yes. Okay. I could just drop a via over here. And now we're connected to ground. Ground. So that's a lonesome pin connected up to the other ground. Have a look on the bottom. Drop a via. Oh, there's pads there again. Let's try up this way. You might also be tempted to, and I used to on my old designs, just drop the via straight on the pad. Wherever you can, avoid doing that. It's not good practice. It's, I don't know all the reasons. I guess it's just to get more contact for the chip that's going there. But anyway, best practice is off the pad. And then more ground. Over there. All right, so looks like we've got ground. If I look now at unrouted 38, so we've done a good chunk of what we need to do. I don't really like the look of that acute angle, so I'm just going to do that. Okay, so now if I come back just to see, already it looks like we're making some headway with the traces and connection to ground. If I put the mask back on, you can still actually see, like you would on a circuit board, you can see the traces coming through now. Okay, good. So what's next? Power is currently sorted. I say that. I say that because sometimes we need to move stuff around once we get into some more of this detail. So in fact, all of those power ones, yeah, I should be able to go like this and hide all the power ones. And all right. So now let's have a look at all these other connections. Drag, draw. Ooh, I see a potential problem here. The reason for these spokes coming out is for heat dissipation. And the rules checker is going to complain because there's only one spoke attached. You need at least two. So I'm just going to draw a line, maybe the other way around, between those two grounds. Otherwise, it's going to moan. All right, and then input A, nice and close. Input A. Now I'm just drawing to get rid of lines. These are the rat's nest. So I could come across here, but I want to point out what that's going to do. You see the way the zone fill disappears there? It's because that's the oh, we didn't change it on this layer, did we? Let's have a look. 0.2 clearance, 0.2 happy. Okay, refill. Looking much neater. It still can't get in there, so I could do that. And hey, look at that. We've got some more. We've got some more spokes. I'm, however, still, if you trace this zone around, you'll see it's got to come through here. And, if I had to do something silly like that, now this section is disconnected actually from this area, which means that those zones aren't connected anymore. So it's just something to be aware of. So what I often do is I think, well, I use front copper to go horizontal most of the time and blue copper to go vertical most of the time, or the other way around. It just means that you don't end up with so many. You see how little is happening on the front copper here. So we could just switch to front copper, go across, drop a via, connect it, and now we don't have that separation anxiety that we were having before. Right. Okay. Let's just connect all these little obvious things. It'll be the same down here. Quick wins. Now, same deal. It's not actually that much of an issue. So if I go like that. Right, now there's this input net coming around these pins. So if one approach would be to, yeah, okay. So one approach would be to pull up here all these and just place wires. Yeah, that should be fine. And what that should allow us to do is drop a trace here. Let me just move it out so it can fill that zone a little better. And then I could take this across here and just connect these all up. And now we've got all those inputs connected. Now the other side is going to be a little more tricky because, well, we could do it like this. Yeah. So this is where the trickiness comes in because, so we need to drop a wire here. And now, we can just fit one in there. In fact, what's on the back? Right, there's a big ground over there. Let's see what's possible here. Okay, so I don't even necessarily need this one. Let me just take it up like that. Okay, I've still got to connect across there. And that should be possible like that. We're getting there. 17 unrooted. That's not bad. It's always quite exciting when it says 1,300 and whatever not rooted. Then you know you've got a more complicated circuit. All right, so this is now the other input channel. However, we've got that normalized input A coming across into the second channel, right? Which means we've got a nice long trace. So we could theoretically do something like that. We're going to run into some interesting times with this net crossing it. All right, so we've got input, 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 input. So now we've just got to connect those up, which I just want to see this whole. Okay, so it's the mirror of what we had up here with this lot, right? So we need to connect these things up. All right, happiness. Bring this down and then just drop a wire going like so. Oh, 8 left, and I think it's probably all this stuff. So I could drop a via here and the via here, and do something like that. If I select a piece of a trace and press D, it allows me to drag it around, and that might give enough. Nah, doesn't. Maybe if I move this across a bit. Yeah, it gives just enough to get it to fill the zone. I like relatively uninterrupted copper going in between. Yeah, because here we've got a break, there we've got a break, but there it is coming, that plus 12 volt coming through. So, yeah, it's kind of important. I mean, if that does get isolated completely, then it's going to show up, hey, there's a line, a new rat's nest line you've got to connect. So it won't just happen without warning, but yeah. Yeah, so this one, either these two need to connect. I could connect them like that. Ooh, and we drop a whole chunk of the net. Ah, that's better. Still okay. Right, then it wants those connected. So again, I could connect them across like that. Could it have been that simple? And then this one, 4 unrouted. Okay, now this is where it starts getting interesting. Let's just check that all the nets are visible. Aha. Yes, that's what happened. So if I put that back in, we lose. It's not the end of the world, but it's also not wonderful. So to get that filling might be another way to connect. So I could potentially, on these big pads, I actually don't mind that much, just connecting, slapping a via in the middle of it. Great. And now they're all connected via the backplane again. Where are we now? Ah, yes. We needed to connect this stuff up. That up. 0 unrouted. Can you believe it? Let's just see if I can make this a little. There's no way to move. Oh, there. Not very much we can do about that. Okay. So the idea, I guess, now, after all of that, is that we've potentially got, and I might as well just do this, quite frankly. Yeah, it doesn't fix our problem there. So I'll revert to best practice. Okay, but now we've got, that's what our back copper looks like. That's what our front copper looks like. And we've got everything that should be connected is connected. So that's kind of cool. It means that now we have potentially a working board. I'll put the components back on with S and T. we can see what it all looks like. All right, so next up, we will be looking at, arranging. You can see over here now, if I put the silkscreen back on, there's components, references that are chopped off by the solder paste and so on. So all of that stuff we need to fix, so that when we get a nice new board, we can actually read what's going on it. Okay, so that'll be next. And yeah, I think for now, I'm going to call it there and say good luck and do your best at laying out your board. Controls first, power next, power planes, and then figure out your actual component layout. All right. Thank you for watching. Good luck.